Hello everyone. We'll do the last module of the first week. In today's module, I would like to concentrate on the second step of testing. If you remember, in the previous modules, we saw that there were 4 steps involved in software testing. You design test cases, then you automate test case design. That is, you make the design test case ready for execution, followed by the third step, which is the test execution process. And finally, when the test execution results are recorded, you evaluate the tests, right? So the second step in these 4 processes is that of test case automation. And the focus of this lecture is to understand what is test case automation and what exactly goes into it. In the previous module, we saw that testability of a software in turn translates into observability and controllability. And these are measured using the RIPR model, right? R for reachability, I for infection, P for propagation, and the final R for revealing, right? So how do I ensure that reachability, propagation, and revealing are done? I ensure that these 3 are done in the step of test case automation, which is what we will look at in this module, right? So how do we do that? We have to give what are called prefix values to ensure reachability of a particular piece of code. And then once the test case design exercises that piece of code, we have to give postfix values to the test case design to ensure that if there is an error, that gets propagated outside. So all these things are what are called test automation. To formally define test automation, it is the process of controlling the execution of tests and actually ensuring that reachability is done by giving prefix values or preconditions. Then you execute the test and compare the actual outcome to the expected outcome, and then you report the results of your test case execution, right? So we'll recap what a test case is and then see what are the add-ons that we have to do to a test case to make it ready as an executable test script, right? So if you remember from the first lecture, what was the test case? Test case basically contains test inputs and expected outputs. And if the expected outputs match the actual output after execution, then you say that the test case is passed, otherwise it has failed. Right? This is a raw test case that has been designed. Now to make it into an executable test script, the process of test automation has to add prefix values and postfix values to this test case. So what are prefix values? They are basically inputs that are necessary to put the software or the software artifact into an appropriate state so as to be able to receive the actual test case for execution. And after the test case is executed, postfix values come into picture. What are postfix values? They are values that are necessary so that the results of execution are sent to the software as an observable value by an external user. Postfix values in turn are bifurcated into 2 kinds of categories: verification values and exit values. What are verification values? Verification values basically tell you that an exception has occurred. This test case has passed or it has failed, and it is a value that clearly tells you what is the result of test case execution. And what are exit values? Exit values are basically values or pieces of code that are needed to make sure that after the test case is executed, the code appropriately finishes its execution fully and exits so as to retain and reveal the error state if there was any present during execution. Right? So now if we take the raw test case as it was designed and make it ready as a test script to be executed, what are the summary of things that it has? It has the actual test case values, the prefix values, the postfix values, and as I told you, it also has the expected outputs, right? So when we put it all together and get it ready, our final result at the end of the test automation step should be to be able to get an executable test script, which is a test script that contains all these values and can be executed directly on the piece of code that it is being tested on. Right? So I will explain in detail how to give prefix values, how to give postfix values, and what happens in the process of test automation by using this open source tool, very good open source tool called JUnit as an example. Later in the part of the course, when we see several examples of Java programs or C programs, you could use the JUnit framework to be able to experiment with the test cases that you have designed as a part of assignments or other lectures that we will see in the course. This module is not meant to be an exhaustive introduction of JUnit, but it's more meant to be used to interpret JUnit as a test automation tool, as a framework to understand how test automation works. In that process, you'll also learn some of the commands of JUnit, which will be useful when you run your own experiments with JUnits at later points in the course. So what is JUnit? It is an open source testing tool, very popularly used in the industry. You can download it from junit.org. And what are the things that it supports? It is very good for writing and executing test scripts. So once you design a test case, you can automate it using JUnit and you can execute it and evaluate the results also using JUnit. It can be used as a standalone entity on Java programs, or it can be used within an IDE like Eclipse. So what are the high-level features of JUnit? JUnit supports what are called assertions. How are assertions used? Assertions are basically statements that will always return true or false. You can view as an assertion as if it returns true, then everything is fine. The test case is passed. If an assertion returns false, then there is an error that has been found, and you can use this assertion to be able to reveal the error to the tester. Right? So we'll see assertions, how to use assertions through examples in JUnit. JUnit also has test features for sharing common test data. Let's say two people are writing a common piece of code and they want to be able to share the test cases that they are writing, then you can use JUnit to be able to do that. And JUnit also has suites for easily organizing, running, executing, and observing tests. And of course, like many other tools, it has a textual interface and it also has a graphical interface. So what can JUnit be used for testing? The main thing is JUnit is used for testing Java programs, right? So it can be used as a very good unit testing tool, or it can be used as a very good integration testing tool. It obviously cannot be used as a system testing tool. In system testing, if you remember what I had told you, we take the inputs, put the system as a part of the inputs, as a part of the server, connect it to the database, and let the outputs be observed as commands and so on, right? JUnit, being a testing tool for Java, cannot be used for system testing, but can very well be used for unit testing and integration testing phases, right? So it can be used to test an entire object. It can be used to just one methods or certain interacting methods within an object. It's up to you, right? So JUnit has what are called test methods, and each test is embedded into one test method. Then it has a test class that contains one or more test methods. Test class, apart from this, can also have methods that are used to set up the software to the state before and update the state after each test, right? So the methods can also be used to run the prefix and postfix values that I was telling you about. And then there are core test methods, which actually contain the test cases that have to be executed. So how do I write tests for JUnit? The first thing that we will understand while writing tests using JUnit is to be able to use assertions. As I told you a little while ago, what is assertion used for? You assert is like a debug, but in the context of testing, right? So I say assert something if this test case passes, assert something if this test case fails. Assertion is always a Boolean expression. The value inside an assert always evaluates to true or false. The implicit understanding while writing assertions is that if it evaluates to true, then everything is fine, your test case is passed, so you can move on. But if an assertion evaluates to false, then it indicates, or it might indicate, an error state. So you typically put a print statement there, right? Say what has gone wrong, and you throw an exception, or you print an appropriate warning, and so on, right? So each test method that is used inside JUnit basically checks for a condition, which is nothing but the assertion, and reports to the main test runner method about whether the test has passed or failed. right? The test runner method uses the result of this assertion failing or passing to be able to report the result to the end user. And here are some examples of how asserts run. So it is present in JUnit.framework.assert. So you can do something like assert true boolean. So this just says that if this boolean predicate inside this assert true evaluates to true, then you just quietly say that it's true. If it evaluates to false, maybe it will give a warning and terminate if required. The second assert true takes two arguments. It takes a string and it takes a boolean predicate. The idea here is that if the boolean predicate evaluates to be true, then you don't do anything. And if the boolean predicate evaluates to be false, then you print the string. So it can be used as a way of warning the user. A third assertion is what is called fail assertion, which basically says only if it fails, if a particular thing fails, then you output a string as a warning to the user. So when we see examples of code that we write with JUnit, I'll show you examples of how to use all these assertions. So now how to write a test fixture, right? Assertion is the core component which tells you when a test case is passed or failed, right? Now we have to write still prefix values, postfix values. How do you do that, right? So how do I do that? Prefix values are initialized in what is called a before method, at before method. And postfix values are given in a method called at after method, right? The names are very intuitive and very easy to remember. So I'll first walk you through a couple of examples. We'll start with a simple code for addition as an example. Then I'll look at another example which returns the minimum element in the list and tell you how to write prefix values, how to write postfix values, how to give the test cases, and how to write assertions that will output the result of the test case passing or failing. So we'll start with an example of a code that does addition. So here is an example of a code that does addition. There's nothing complicated to it. It takes two integers a and b and it returns the sum of a and b, which is a plus b. Right? Now suppose you're given the task of testing this code, right? So let's recap and understand what a test case is. So test case should give inputs and it should give expected outputs. What are inputs to this piece of code? Inputs are one value for a and one value for b. And expected output is the actual sum of a and b, right? Now what you have to do as a part of the automation, you say that you please take these inputs and compare it to the expected output. If the actual output matches the expected output, fine, everything is working fine. But if the actual output differs from the expected output, then you use assertions to be able to flag the fact that the test case execution has failed. So how will you do it in JUnit? This is how you do it in JUnit. So these are standard things that you have to import every time you write any program, any test method using JUnit for test case automation and execution. So you import what is called JUnit.test and you import this library of assertions. Right, so I am writing something called the test for the calc method. How do I do? So I write these two statements. The first statement says that you assert true and it gives a string, right? And the second statement actually runs the addition code that we saw in this slide with two actual test inputs, 2 and 3. And if 2 and 3 are the test inputs, assuming that addition works correct, what is the expected output? The expected output should be 5. So it compares it to 5. So what it says is that you run this add program on inputs 2 and 3 and check if the result that is outputted by the add program on these inputs is actually equal to 5. If it is actually equal to 5, then you exit, test case is passed. But if it is not equal to 5, if the calc program actually has an error, in this case it doesn't have an error because it's just a simple program that returns a plus b, but assuming that it does have an error, you write it for some other program, then this assert true will take over and it will output this string. So it will say that calc sum is incorrect. So it will say that there is an error somewhere in the code, right? So now we'll look at another example, slightly longer than that simple toy addition example. So this is an example of a piece of code, Java code, that returns the minimum element in a list. So this code is very well debugged in the sense that it takes care of all exception conditions. It takes care of what if the list is empty, there's nothing to return. What if the list has entities that cannot be compared at all? For example, suppose the list has a string and a number. The list has a string and a boolean value. They are of different types. They cannot be compared, right? So in all these cases, this code is meant to throw several different kinds of exceptions. So these are what are called a part of debugging, where the developer himself takes care of all the corner cases like wrong inputs, wrong data types, etc., which need not be taken care of by a tester. So this code is well written to be able to take care of all the exceptional cases. Of course, the tester's job would be able to test for all these features also, as we will see through examples. But we'll first see what the code does and what are the various exceptions that it takes care of, right? So this class is called min, and as I told you, it returns the minimum element in the list, and it takes as input a comparable list of elements. What I said is that all of them should be comparable. They should all be a list of numbers, or they should be a list of strings that I can compare them with respect to the lexicographic ordering. They should not be incomparable types. And what is the main functionality of this class min? It's supposed to return the minimum element in the list. And as I told you, this class min is also supposed to take care of exceptions like wrong inputs, incomparable inputs, and so on. So it has several exceptions. The first exception that it has is what is called a null pointer exception. It throws this null pointer exception if the list is empty or if any of the elements of the list are empty. And the second kind of exception that it throws is what is called a class cast exception, which it throws if the list elements are not comparable to each other. As I told you, one is a string and the other is a boolean constant. How do you compare them? So you have to throw an exception. It also throws an illegal argument exception if the list that is passed to it is empty. There are no elements to compare, right? So I have split this code across 2 slides because otherwise it won't be readable. So we'll move on and look at the rest of the code in the next slide. So what does the main code look like? This is how the main code looks like. I'll just glance through it because I don't want to read the code line by line. It's just a standard written Java program that takes a list, right, called T, and then if the list is empty, then it throws an illegal argument exception. Otherwise, it repeatedly compares it to the next element in the list and returns the result in this value called result. It returns the minimum element, right? So this is a piece of Java code. So just to recap what its main functionalities are, it takes a list of comparable elements as its argument and then returns the minimum element in the list. Suppose the list doesn't have comparable elements, the list is empty, the list has other kinds of problems, this code does exception handling very well. So now our job is to be able to design test cases for this minimum program and see how you can use the second step, which is the test automation step that is the focus of this lecture, to be able to test this program, right? So how do I do? The first step, as I told you, is because we want to be able to use the tool JUnit, we have to import all these standard classes. You have to import JUnit assert, you have to import JUnit, you have to import the util library, right? After this, the next job is to be able to give prefix values and postfix values to the code. How is that done? Prefix value is given by this kind of, as I told you, right, by this at before thing. So what you do is that you give a test fixture and a pre-test setup method. So you have it like this, you give it a list, which is a test fixture, and then you set it up, which is called before the main test method. The main test method actually has the test cases for execution. So you say that this is the thing and I pass a new array for this. And after this, in the main test case, the main test method would be called, containing the test cases. And post this, I have what is called a tear down method, which gives the postfix values, which basically in this case is not relevant because there is nothing much to do. But assuming that you had a fairly large piece of code, postfix tear down method will actually do the rest of the execution to be able to see the output as being produced by the code. In this case, because it's a small example, we will directly see the output. So there's not much postfix activity to be done here, right? So here is an example of a test case that uses the fail assertion. If you remember, I had told you there are three kinds of assertions. So if you give me a few seconds, I'll go back to that slide. And yeah. So here, remember, there were three kinds of assertions. I used two different kinds of assert trues, which basically return a warning if this Boolean string that is passed to it, if this Boolean predicate that's passed to it is returned false, or it returns a string if the Boolean predicate that is passed to it is returns false. And the third kind of assertion will return the string if it fails. So here for this min example, we will use the fail assertion, and here is the test case that uses the fail assertion. What is this test case method called? It's called test for null list. It's a void method, and it passes an empty list, and then it tries to see if the code actually throws a null point exception. And if it doesn't throw a null point exception using this try and catch, it will use the fail assert to say that it had actually expected a null pointer exception, which didn't happen. So there is an error in the code, right? In our code, this will not come because this error is handled, right? So here is another example of a test case that tests our min code for the special case of an empty element. So what it says is that I try to add an empty element to the list, and I try to compute its minimum. And in this case, because the code is well written, this is also taken care of. It will return fine, and there is no error in this code even for this kind of test case, right? Now, what are the other things that we can do with JUnit? We saw two examples. This is with testing for two exception cases. Of course, you can go on testing this minimum code for several other exception cases because the code handles several other exception handling mechanisms. But suppose I have to test the main functionality of the code. What is the main functionality of the code? The main functionality of the code is to be able to give a list of elements that are comparable and check if it actually returns the minimum value from the list. So for that, I need to be able to give data, right? I need to be able to pass a list of comparable elements. How does that happen? How does one do it with JUnit, right? For giving data to tests with JUnit, we have a constructor for them. So that constructor, what it does is that you can pass several different data to it, and the same tests are run for each set of data values. And the collection of these data values are defined by a method tagged with @parameters. So it basically helps to test a function with multiple test values. So I can test a minimum function with several different lists and check for each of these lists, does it return the minimum, right? I can check the add function, that other toy example that we looked at, with several different arguments A and B, and check in each of these cases, does it actually return the sum of A and B, right? So I'll go back to the add example and show you how to use this @parameters with the constructor to be able to provide data along with prefix, postfix, and asserts, right? So here is the complete JUnit program for the same. So I import, as I told you, all these various classes. Now what I do is I have to pass data, right? Now I'm going back to the add example. So I have to always pass two integers A and B to it and check if the sum of A and B is actually returned by the addition code, right? So I use this constructor, and then I write this particular class that does the main testing. So how does this work? If you see, this dot A is equal to V1 and this dot B is equal to V2. These are the variables that I use to pass the actual parameters, right? And then the expected result is stored in this dot sum. And if you go here, there is an array which the first values, set of test case values that it passes are A is 1, B is 1, and the expected result is 2. The second set of test case that it passes are A is 2, B is 3, and the expected result is 5. In this example, I have just given 2 so that I can explain it to you, but you can pass an array of as many test cases as you want along with their expected outcome, right? So what it will do is it will go back and execute this particular method. Right? It will execute this particular method, and in any case, for whichever test case, if this assertion fails, then it will output that this sum is incorrect. how it does is it will do it for each of these test case values and the expected output, right? And it will finally exit without giving any assertion violations if all of them pass. So for our particular example, the calculator addition was correct code, so it will pass for all these examples. So similarly, for the minimum element in a list also, you can put it all together, right? Check it for various null pointer, empty list, and other kinds of exceptions. And after passing all these exceptions, actually use this constructor class to be able to pass several different lists of values and their minimum element, and check whether the code actually returns the minimum element from this list. Because that piece of test code in JUnit is fairly long to write, it wouldn't fit into even 2-3 slides. I haven't given that as an example. What I can do is I'll be putting it along with my notes. Feel free to look at it, right? So hopefully at the end of this exercise, you would have understood how to give prefix values to a test case and how to actually give the test case values, write asserts that will indicate whether the test case is passed or failed, and if needed, how to make postfix values in the code such that the assert failure or assert pass actually reflects as output in the code. To understand this, we used JUnit. JUnit is a fairly extensive tool. As I told you in the beginning, the purpose of this module was not to be able to teach you exhaustive features of JUnit, but to be able to teach you how to use JUnit for test automation. So feel free to go download JUnit and explore all its other features and try it out on your own Java programs to be able to see if you can test them or not. Right? So where are we going on from this? Right? So now we saw how to automate. And once you automate and execute, JUnit also has an execution framework. As I told you, it is fully command driven, fully automated. So there's nothing much to discuss about it. I won't be discussing about that in detail. After that, you actually observe by using assertions the result of failures. Now, if you go back, right, to the first step, right, that is test case design, it actually tells you what are the test cases that you pass on to a tool like JUnit for automating, right? How do you design test cases? How does one go about giving effective test cases without giving blind test cases and not hoping to find any errors? So for this, we go back to the problem of test case design. So we will look at criteria-based test case design. We model software using different mathematical models or structures, as I told you, graphs, logical expressions, sets, and so on, and teach you how to design test cases based on each of these. So that will be the focus of my lectures beginning next week onwards. Thank you.